Okay, so for the continuation of our discussion, we will be discussing about voltage divider. Another type for BJT DC biasing configuration. So voltage divider is the most popular way to bias a transistor. The advantage lies in its stability. If designed properly, the circuit is practically immune to changes in BDC or beta, that's beta, by either transistor replacement or temperature variation. An example of voltage divider bias is shown in the figure. Notice that the VB is voltage measured from the base lead to the ground, which is actually the voltage drop across the R2. Since the voltage divider is made up of R1 and R2, VB can be calculated using the voltage divider formula. In your class, this is our base lead to the ground. This is VB. Okay, that's our VB. Okay, that the VB is the voltage measured from our base terminal or lead to the ground, and that is basically the voltage drop of our R2. Okay, because in here, atong VB is opposite sa atong R2. Okay, so that's the V drop. And the VB can be calculated using the voltage divider formula. So VB is equals to R2 all over R1 plus R2 multiplied by VCC. The same ra na paagi ani class, the same na siya og okay, same na sila. VB. Okay, na naragihapon ang naong sa ato ang voltage divider formula. We have here, there are two methods that can be applied to analyze the voltage divider configuration. The first to be demonstrated is the exact method, which can be applied to any voltage divider configuration. The second one is referred to as the approximate method and can be applied only if specific conditions are satisfied. The approximate approach permits a more direct analysis of the savings in time and energy. It is also particularly helpful in the design mode to be described in a later section na lang. So all in all, the approximate approach can be applied to the majority of the um, situations, and therefore be examined with the same interest as the exact method. The first method here is the example analysis. The input side of the network be reproduced as shown in the figure below for the DC analysis. The Thevenin equivalent network for the network to the left of the base terminal can then be found in the following manner. Diba this is our, hold on. Now that class is sa ato analysis uses the Thevenin um working model. I don't know if you're familiar with Thevenin, kung siya sa nodal, VDD, CDD, kana sila pamaagi, compute any semi complex nga circuit. Okay, we have here, di ba mani ang ato ang what they call this? Mo man ang ato ang voltage divider nga circuit. We have a VCC, RC, we have RE. But sa atong voltage divider is composed by this two resistor, the R1 and the R2. Okay. R1 and V R2. Now, okay. So many. Okay. So for voltage divider, as I've told you earlier, it is posed by our R1 and R2. Now, in the first step, our Thevenin network theorem. Okay. Now, si R2 here, this is our R2, right? So, kana siya R2. Ang Thevenin ang good class and sphere form is we need to amplify our voltage, i-series to siya sa atong resistor, and connect na to siya sa tuang put. Now, is to put our Thevenin net Thevenin nga theorem or network theorem. Now, in here, dili ka dayan nuog sa ato ang mga resistor o sa source because dagan og agian nga mga nodes terminals. Here, dili terminals lines. Okay, now in here, in order for us to achieve this, no, in order for us to achieve this, need to make this first. Now, look at here. This is our two. One na siyang below. But in order for us to look for our voltage, Thevenin voltage, or iwag na siya og EH. Okay, that's Thevenin voltage, and this is Thevenin resistance or resistor, and this is our output na. About kana, kana class. Pigyapon. Karamog man ako. Or pigyapon.
Yes,
Hello,
ma'am.
hello, hello.
Dungog lang, miss, pero
Tungog miss
maputol-putol
pero
lang siya.
sometimes kay putol-putol.
Sige, interrupt ko ha in case magputol.
Sige miss.
Okay. So, nako. So this exact analysis uses our Thevenin, sorry, Thevenin theorem. Now, since nag-use man Thevenin theorem class, ang atong aim is to simplify our circuit. Now, what do we need to do to simplify our circuit using the Thevenin? So, atong Thevenin class, to simply put it, no, this is just the, here, the VTH, or gitawag na siyang ETH class, our RTH, the Thevenin resistance, and diretso na sa atong output. And in order for us to achieve this simpler circuit, series circuit,
Excuse me, miss. Umuwi
oh,
hapon, miss.
okay, hold on.
Putol-putol jud siya, miss.
Sige, sige. Sa siguro na internet kay kamo man putol-putol.
Lag yung mga internet karon miss.
Sige, hold sa. Wait sa kadit class ha. Can you hear me?
Di echo miss.
Kana.
Okay na, miss.
Okay na?
Yes, miss.
Okay. From the start, putol siya ako ingog. Yes?
Yes, miss. Wala may kasabot kayo, miss.
Okay, okay, okay. Chap na pun karon. Chapi, chapi. Okay, balik. Okay, so sa exact analysis class, it uses the so-called Thevenin's theorem. Now, in Thevenin's theorem class, to simply put it, ato i-simplify ang atong voltage nga nato na siya VH or resources tawag na siya VTH. Miss yung internet, miss? Okay. Choppy. Okay. So, in here, ang resistor kita na siya resistance na to, Thevenin resistance. And in here, after masimplify na duha, connected na siya so sa atong motor. Any connection asa ni next i-connect. Now, Thevenin's theorem class sa atong voltage divide, kani siyang part diri ang iyang gi-simplify. Kaya nga part. Kani. Ng VCC, R1, and R2. Oh, what's happening? Hindi lang ako. VCC over R1 and atong 2. And in here, if you look at here, still, am I still happy? So, in here, mas gibutang na si R2 diha. Okay? R1, kung imagine nun, do not find the capacitor, okay? Iyang gipagda si R1. Okay? Iyang gibutang si R1. R1 is connected to our VCC. Kaya supposed to be na mabutang si VCD ha. Right? Butang na si VCC ha. But to make the circuit more visually dali man ba? Yang IC source and connected na siya. And this is connected to our ground na. Okay, so this one here is our Thevenin circuit. Okay, these are the components that are needed to be transformed. In order for us to transform that, we need to use this, the RTH, right? RTH voltage source is replaced short circuit equivalent as shown. Now, in your class, this is our first nga transformation from voltage divider bias into a Thevenin circuit, right? Then, in order for us to know unsang pagkuha ni RTH, gi-short circuit niya si VC, circuit na niya. Pagtan-aw mo sa nabilin R1 and R1 and R2 parallel to each other. So, kung ano to sa RTH, si R1 is parallel to R2, which has a formula of R1 times R2 divided by R1, R2. That's the formula for our parallel distances. Now next, we have our ETH, our VTH. Okay, voltage source VCC is returned to the network. Open circuit voltage of the figure determined as follows. Now applying voltage divider rule gives EH, which is voltage drop across our R. That's R2 VCC divided by R1 plus R2. It was this formula with our voltage divider. Ang nakalahian nila class ETH ang iya giga. So far, nakako. Class? Still following?
Putol-putol, miss, ang imong audio.
How about the others? Choppy, you have class?
Mao ko, miss.
Yes,
Miss.
yes. Copy dyan kami.
sa amuan ni
Yes,
miss.
yes.
Feel ako sa ako siya kay kamumantan na. Wait.
Yes, miss. Ay mo get niya. Samo po, di na po damo aron.
Saan sa ako ang what they call this?
Sa provider ni miss.
Since the start here, here. Okay, choppy ko.
Yes, miss. Wala man din kuan kay basig makuan ka.
Okay. Kung ari ko mo tabi, dili ko chapi.
Dili, miss. Mas clear ara, miss.
Sige, sige, sige.
Sinaypay biko.
Hello. Hello? Can you hear me?
Yes, miss.
Yes, miss.
Hello, hello, hello. Marunong ko na yung class.
Madungog
Yes,
ra, miss.
Choppy ka sa kuha, miss. No, sa kuha rin ni miss. Akong data, ini.
Okay. Kana. Hello.
Dongogrames.
Okay. Okay. So for this, akong baliko na pod. Class, i-cut off din ko ha kung mag-choppy. Okay. Pero alam po to yung i-cut off bisag dili choppy no. Okay. So in here, So in here, our exact analysis uses Thevenin's theorem. Now for our theorem class, to put it simply, we have our voltage here. Pangalan na siya o VTH or ETH. We have our resistor here. Lagi pangalan og RTH. Then after an aduha, ma-simplify, ma-connect na siya to any output that you want or you desire. Asa nimo siya i-connect. Now, in order to first atong unang buhaton class is to transform that um voltage divider nga circuit into a simpler one. Now, to do that, CR1 um saan wala internet? Okay. CR2 gias is niya CR2. Okay? CR1 class kung imo na imagine nun gipahigda niya si R1. Okay, si R1. And R1 is connected to our VCC. And to have a good visual representation sa atong Thevenin circuit, gisumpay nila si VCC here. Connected, and then connected siya sa atong ground na. Okay, now this is R2, R1, and our VCC. It's the same here. Okay, now next, we need to have our VTH or RTH man. Now, saan man na to? Now, in here, our RTH is the voltage source is replaced by a short circuit equivalent as shown. So we have from here class we have our R1 and R2. Now in order for us to know unsa atong buhaton ni R1 and R2 sa Thevenin network theorem iyang gi-short circuit first si VCC. Then pag short circuit niya diha, so wire na lang na siya diha. Pag tan-aw na to is R1 and R2 are parallel to each other man. So ang formula ni RTH is R1 parallel with R2. Now for the parallel connections at our resistance, we have the formula R1 times R2 divided by R1 plus R2. So that's our RTH. Now, for our ETH class, the voltage source VCC is returned to the network and the open circuit Thevenin voltage of the figure determined as follows. Applying the voltage divider rule, it gives VB or ETH or VTH. That is the voltage drop across our R2, and it has the voltage divider formula R2 VCC divided by R1 plus R2. So that's how we can acquire or we can get our RTH and ETH. Now, after that, the voltage source is replaced by a short circuit equivalent as shown in the figure below, and IB can be determined by first applying Kirchhoff's voltage law in the clockwise direction for the loop indicated. Dili na siya short circuit class. Sep na siya. Ibalik na diha ang iyang voltage source. Okay? The voltage source VCC is returned to the loop or to the network. Okay. Now, to loop class, we need to do this. So that's ETH minus, okay, plus, this is plus minus RTH, IB RTH, because we are doing KVL, okay, Kirchhoff's voltage law, and then VBE, okay, minus IE RE equal to 0. Okay, now that's the loop for our voltage divider. Now, in that class, we have this already, di ba? Now, next step is substituting IE equals beta plus 1 IB and solving for IB yields IB equals ETH minus VBE divided by RTH plus beta plus 1 RE. Miss, kiunsa na pagkuha, miss? Di ba si IE is substitute na tong beta plus 1 IB. So, nahitabo class, mahimo na siyang ETH minus IB RTH minus VBE minus beta plus 1, beta plus 1 IB RE equal to 0, right? That's beta plus 1 IBRE equal to 0. And this one here is our IE. Ngag in terms na tuog IB. Follow?
Yes, miss.
Okay. Now from that, atong gi transpose any term nga nay IB to the other side of the equation. So that's IBRTH minus IB beta plus 1 RE equal to ETH minus VBE. Okay, muna na siya class. Now, um, what do you call this? Kuhaon mo ang common sa sa left side sa atong equation. So, ang common nila is IB, right? Mahabilin, IBRTH, kuhanin mo IB, ang mahabilin na lang si RTH, plus beta plus 1, RE, equals to ETH minus VBE divided by RTH minus beta plus 1 RE. RTH minus beta plus 1 RE. IB equal to ETH minus VBE RTH plus beta plus 1 RE. And it is the same with this IEI. It is the same with this one. Now, once IB is known, the remaining quantities of the network can be found in the same manner as developed for the emitter bias configuration. That is VC equals VCC minus ICRC plus RE. Ganun na ana siya, miss. Okay. Now, in here, okay. Now, for this one class, don't worry, ako naman ang ipon. Now, for this one, nganong si IC na yun, ani na siya. Now, for exact analysis class, di ba si IE is equal to IB plus IC, right? And IB is very much negligible because of its very, very, very low value. So that's why CIE is almost equal to IC. And in this exact analysis class, CIC o CIE gas is niya same ni IC. So that's why, di ba, i-group na to. That's VCE, VCC, di ba, i-group class. Here, di ba, it's VCC minus ICRC minus VCE minus IERE, right? Equal to 0. That's our collector to emitter loop nga KVL equation, right? Class, still following?
Yes,
ICRC
miss.
minus VCE minus IERE equals 0. Now, given this condition, we can have this one. VCE is VCC minus ICRC minus IERE. But IE equals to IC. So therefore, VCC minus IC, RC minus ICRE. Combine RC and RE having the same or common current for them. So that's IC. Muna siya ang equation class. And that's for exact analysis. Okay. Now next we have here a sample problem for a voltage divider bias configuration using exact analysis. We need to find ETH, RTH, IB, IC, VCE, VC, VB, and VBC. Now how to find those? Siya. Dili na ko choppy. Kas.
Yes, miss. Okay na, okay na, miss.
Okay, so dili na kayo choppy. Alright, now we need to find ETH, RTH, IB, IC, VCE, VC, VB, and also VBC. Now in finding those, VTH, unsa gi formula sa atong VTH? Unsa to'y formula sa atong VTH? We have the formula of our ETH, that's the voltage divider um, formula. So that's R2 VCC divided by R1 plus R2. We have our R2 here, or our R lower, so that's 3.9K times VCC of 22 divided by R1 at 39K plus 3.9K. And this one is equal to this is equal to 2 volts. That's our ETH. Next, we need to find our RTH. And in finding our RTH, R1 is parallel with R2. So that is R1 times R2 divided by R1 plus R2. Now R1 is 39K multiplied by 3.9K divided by 39K plus 3.9K. Now this is 3.55 kilo ohms. So that's our RTH. Next, we need to find our IB. Now, in getting our IB, we have the formula of our IB of here. IB is ETH VBE, right? Divided by RTH plus beta plus 1 RE. Okay. So ETH would be 2 minus 0.7. R RTH is 3.55 K plus beta at 100 plus 1 and atong RE is 1.5 K. So atong IB should be so that's 8.38 microampere. Okay, so that's our IB. Therefore, having that IB, makuha na to si IC at beta IB. Beta at 50, 100 multiplied by 8.38 microampere. So that would be so that's 0.838 milliamperes. Okay. Now for our E, so that's E. We have the formula of our VCE of VCC minus IC RC plus RE. Right? So VCC at 22 minus IC at 0.838 milliampere, RC at 10K, RE at 1.5K, okay, VCE so that's 12 point 12.36. Am I right, class?
Yeah, yes, Miss. Pareta, Miss.
36 volts. Okay. Now, if you do 22 minus 0.84, kung inyong giround off si IC, multiply ni mo ni 10, 1.5K, ang imong makuha na is 12.34. But in here, I am using 0.838 man. So, we have come up with that. Hold on, class. Miss. Miss. Ano sa'yo mga activity sa SSG ron? Kakuyaw. Okay, going back, sorry. So we need to find VC, right? Now in finding VC, unsay mga pamagi sa pagkuha ni VC, we have a VC equals VCE plus ano yan? So VC would be VCE plus VE, or we can do loop. So VCC minus ICRC minus VC equals 0. Let's try if they have the same. Let's try this one, the loop. So that's VCC ICRC. VCC would be 22 minus IC at 0.838, RC at 10K. So therefore, atong VC is at 13.62. Do we have the same answer?
Same ra, miss. 13.62.
Okay, 13.62 volts. VE, VCE, 62. Okay, now for the VC class, as you noticed here, VCE plus VE. Now sa atong VE class, di ba? Don't mind the capacitor. As I've told you earlier, pwede ta maka-ohms law ni VE, right? Because VE is standalone terminal here. Di na siya moagi og lain pa nga terminal. Now to ohms law, IE equal VE is equals to IERE. But in here, ang IE na to is equal to IC, right? ICRE. So therefore, that's 0.838 multiplied by our RE nga 1.5. Okay. So VE na to would be we have 1.26 or 257 volts, right? And plus na to siya o VCE nga 12.36. Yung mo lang taning 26B. So 1.26 volts, okay, mo na itong VE. So therefore, if we're gonna use this one, so VC equals VCE, ang sa itong VCE, 12.36 plus VE at 1.26. So that would give us 13.62 volts. It's the same with this one. So that's our VC. Now for the rest, okay, unsay paytaon na to next? VB. Right? So VB, letter G man siguro na VB is VBE plus VE. So that's 0.7 plus, what's our VE? 1.26 volts. So that's 1.33. Sakto ba?
1.96, miss.
0.96 na. Save. 1.96. 1.96 volts. That's for our VB. And for EFGH. For the last one, VBC. So that's VB minus VC. VB at 1.96 minus VC at 13.62. So that would be 11.66 volts. So that's how you find the voltage divider bias configuration using the exact analysis. Now, moving forward, we have here repeat the exact analysis of example number 1 if beta is reduced to 50 and compare solutions for IC and VCE. Of our IC and VCE. So finding Nemo. Okay, so our ETH, since it has the same formula sa atong first, right? ETH na to is 2 volts and atong RTH is 3.55 kilo ohms. Di mo dyan na mausab kaya wala mo na usab ang ato ang resistor and the source. Now in here for IB would be ETH minus VBE divided by RTH. Plus 50 plus 1 RE. RE is 1.5. Okay, so this would give us 16.24 microampere. Ako rin na siyang gisave sa kalikip. Sakto ba? 2 minus 0.7 RTH at 3.55 plus 51 times 1.5. 54. What am answer class? Sayop. Sakto lagi. 24 microohms. So for letter D, I see that beta IB. So that would be 50 multiplied by 16.24 micro. So that would be 0.8012 milliamperes. We have our VCE. So that would be VCC minus VCE would be VCC minus ICRC plus RE. So this would be 22 minus 0.812. RC would be 10K plus 1.5K. So that would be 12 point. That's 12.66. Sakto mas? Okay. Now, as you noticed from the first example, ang at IC from beta at 100, okay, ang IC is 0.88 milliampere, and ang VCE is at 12.36. Now, when the beta reduced to half, that's 0.12 milliamperes. This is 12.66 volts. Okay. Now, when you look at the what I call this? Now, when you look at that um observation, you can see that there's no or wala jud kay kausaban kaayo when it comes to our IC and BCE. If imong ready to have C. So that observation class, it clearly shows that the dili sensitive the circuit to the change of our IB. So the voltage divider bias here is beta independent. Follow?
Miss Mara po.
Class?
Ay kagamay, miss.
Ha? Choppy ko?
Happy na sad ka, miss.
O, dara, itong kuan part na miss na
Asa
wala
ka
akong
dapit?
saban.
Asa dapit? Can you still hear me? Di ko kadungog ninyo.
Dungog ra, miss. Atong nga part nga itong nana ka, miss, naka-observe ba sa kanang mura ka ng table nga imong game mo.
Okay. Now, ang kang table class, our first example, bottom beta is 100. We have the IC of 0.838 and our V at 12.36. Now, for our second example,
So,
narrow
miss,
down.
Shopee gid ka, miss.
Okay, hold on. Ganun.
Ay,
Hello. Can you hear me? Gus, can you hear me?
Yes,
Yes,
ma'am.
miss.
Ma'am.
Okay. Hinaot naman chapi-chapi. Okay, going back. So for this kung himot nga table class, you can from our first example, itong beta is 100. We have IC of 0.838 milliampere. We have our VC at 12.36 volts. Now for the second example, we narrowed it down, or we have the beta down to 50, and after narrowing it down, we can achieve the 0.812 milliampere, and for a VCE, that's 12.66 volts. Now you can see there is not much difference, only the decimal places. Well, but sa atong whole numbers, we don't have any changes, right? So since we don't have any changes, despite um, cutting the beta in half, no, down to 50, there is no drastic change between our IC and VC, therefore making this circuit or a voltage divider bias and exact analysis and beta independent. Copy? Copy, Gus?
Yes, miss.
Yes,
Okay.
miss.
Okay, next we have here voltage divider in approximate analysis. The condition that confirms whether the execution of the approximate method is feasible or not is decided by the equation. Now, for the definition of our voltage divider class, if you can remember, natay duha ka pamaagi, namely the exact and the approximate. Now, in here, the approximate um, method can be applied if and only if specific conditions are satisfied. Now, what are those conditions? Now, this is the main condition, whether kung masatisfy siya or dili. If masatisfy ta, then we can use directly our approximate analysis. But if it's not satisfied, then we can proceed to use our exact analysis. Knowing this is for the condition that needs to be satisfied. It should be our beta multiplied by our RE should be greater than or equal to the 10 times our R2. Now, if that condition is satisfied, then we can proceed to solve or compute our um, circuit or voltage divider circuit using that approximate analysis. However, if it does not satisfy the said condition, then we must use the the exact analysis. Now, in here for our approximate analysis, we have the VB. Okay, it's the same with the voltage divider. The voltage across R2, which originally would be the base voltage, could be evaluated as shown below by applying the voltage divider rule. So that's VB R2 VCC divided by the sum of our R1 and R2. Now, once VB is determined, the level of a VE can be calculated from VE equals VB minus VBE. Now, from that calculation of VB, makuha na, the emitter current can be determined by IE equals V over RE, or IC is almost equal to our IE. The same with our exact. Now, once IC is known, the collector to emitter voltage is determined by VCE equals VCC minus IC RC plus RE. It is the same with our exact analysis. Okay, follow, plus,
Follow ra, Miss.
okay. Sa atong approximate class, we're not dealing with any theorem. Nidiretso ra ta or iko ato ra gisatisfy ang kana nga condition, the beta RE greater than or equal to 10 R2. Okay, next. Next. Okay, problem solving na di ay. Okay, determine the following for the voltage divider bias configuration: VB, VEIEIC, VCE, VC, and VBC. Okay, now what's the formula of our VB again?
R2 VCC over R1 plus R2.
Okay, hold on. Okay. For our VB, can you still hear me? Yes.
Yes, Miss.
Yes.
Okay, for our VB, we have the formula of, hold on, before that, Nakalimutan ko always. We need to see if satisfy ba niya ang condition. So that's beta RE greater than or equal to 10 R2. We have our beta at 100, multiply at RE 1.5K. It should be greater than or equal to 10 times of our R2. R2 at 3.9. Okay. Now this is 150K and this is 39K. 1, 2, 39K ohms. So therefore, the condition is satisfied, right? Therefore, na po, we can use or we can apply the approximate analysis. In approximate analysis, we must find first our VB with the formula of R2VCC, R1 plus R2, R2 at 3.9K multiplied by 22, R1 at 39K plus 3.9K, and that is 2 volts. And for our VE, that is VB minus VBE, right? So VB is 2 volts minus 0.7. So this is 1.3, 1.3 volts. Next, IE. Right? So atong IE class, sa formula sa atong IE, that's VE over RE. VE at 1.3 volts, RE is 1.5K. And 1.3 divided by 1.5K, so that's 0.867 milliamperes. That's for our IE. Next, we need to find our VCE. Now for our VCE, okay, for the formula of our VCE, that's VCC, IC, RC plus RE. Right? So this is VCC 22 minus IC. IC is equal to our IE naman plus, diba? Remember here? Okay, so that's IC, it's 0.867 milliamperes. RC at 10K plus RE at 1.5K. 22 minus 0.867 times 10 to the negative 3 times 10K plus 1.5K. So that's 12.03. 12.03 volts. That's for our VCE. And we can find our ano ba tag IC? Nope. Nope. Congrats, Dai. Engineer. Okay. So VEI IE is equals to our IC. Wala na akong ibutang. Idritso na akong E class ha. D is IE plus IC. IE. Ano na siya? So, atong BC, so that's 12.03 volts plus 1.3, that's 13.33, if I'm right. 13.33 volts, that's for our VC. And for our VBC, yeah, VB minus VC. Now for our VB, that would be 2 minus 13.33. So this would be volts. Paano ra class?
Yes, miss.
Okay. Now in here, another example, given that IC is equals to 2 milliamperes and VC at 10 volts, determine R1 and RC for the figure below. Okay. Given that conditions class 2 MA and 2 milliamperes and 10 volts of VCE, we can determine R1 and RC for the given figure below. Now first, unsay mga given si IC o si VCE na inyong hunahunaon asa na nato magamit. Right? Si IC. Asa man na pwede nato magamit si IC? Pwede nato magamit si IC equal ni IE. Right? And from that IE gas, makakuha ta sa atong VE. Okay? VE IE RE. But since IE is equal to IC, so that's IC RE. So therefore, VE would be 2 milliamperes multiplied by our RE. That's 1.2 K. So that's 1.2 times 10 times 10. That's 2.4 volts. Nakakuha na tag 2.4 volts nga VE. Unsa pa ilaing given diri class? Naatay VCC, naatay R2, naatay RE, naatay VBE. Right? Di man naman si VBE. So VBE would be VB, yeah, VB minus VE. So from that, makakuha ta ni VB. So VBE plus VE, VBE is at 0.7 plus VE at 2.4 volts. So this is 3. Diba? Trust issues. 3.1 volts. Nanatay VB, nanatay VE. So ang VB class, remember that is our voltage divider. Kuha na nato siya using voltage divider formula. Diba? VB equals R2 VCC R1 plus R2. Natay VB na natay R2. Natay VCC natay R1. Missing si R1. Natay R2. Natay R2. Therefore, makita na to si R2. Follow? Follow ra ba class?
Yes, miss.
So from that, so that's VB multiply cross multiplication. So that's R1 plus R2, R2 VCC, VB R1. Ako rin i-try ha. VB R2. R1 ang ipakita. So pabili na to ni siya. Transpose VB-R2 to the other side of the equation. Divide both sides by VB. So R1 formula would be R2 VCC minus VB R2 divided by VB. So R1 would be 18K, VCC is 18, VB at 3.1, R2 at 18, VB at 3.1. 18 times 10 times 18 minus 3.1 times 18, 3.1. Sakto ba? Sakto ba akong pagkabuhat kas? Or na sa'yo? R2 VCC. VBR2, R2 VCC. R1. R2 minus 3.1. So R1 would be 86.52 kilo ohms. Nanatay R1. Complete. Nanatay R1. Atong pahitaon na lang si RC. Unsa na to papangita si RC? We can only find RC by looping. IC RC plus RE. Let me try that. If I can find the right RE RC. VCC is 18 minus IC at 2 milli. RC missing plus RE at 1.2. Ay, sayo. Sorry guys, I'm talking to myself. So this would be 18 kuangan minus PCE minus IE RE equals 0. 18 minus 2 times 10 to the negative 3 times RC is missing plus RE at 1.2 times 10 to the 3 minus VCE at 10 minus IE at 2 times 10 to the negative 3, RE at 1.2 times 10 to the 3 equal to 0. Am I wrong?
Miss, sa R1, miss, marag lahi ta, miss.
Why?
Ang R2, miss, ba kay 18K man, miss, ah. 18 ra imong nakuhan, miss.
18K. Sakto bitaw? 18K times 18? Ah, okay, here.
Right side, miss.
Okay. Pero pareho ang answer.
Marag lahi, miss.
Same ra sa ako, miss.
Same sa ako.
Basta naris na yun. 3.1. Pareho itong 86.52.
Ako de lang, miss. Sige.
Okay, try ibalik, try balik. So that's, diba, galibo po papel. Times 3 minus 10 minus RE. RE. Pila makuha ninyo kung kani yung gamiton, guys? Let's use this na lang, be. Malimut ako yun sa ito nakapag-solve. Wala ko kakuha. Kaya may subobo. Oh my God. Wait, sa tiwason sa ko ni klasa. VCCIC minus VC equal to 0. So therefore, this is so ilagay VC na to 12.4. IC is 1.2. IC should be sakto na gid ni. Pizza ka sa galibog na yung kung yun sa kunipag so wala mo ko kunigisulat. Imagine na ko ni. Hold on, hold on. BCE. IERE. BCE Indonesia. Mm. Oh, di ba kabugo yun? Mm.
Tinood na, mas nakag-hayang feel galing ng imong yung call. Pasalamat na lang ko doon dito kay hindi magubang imong pwesto pa mo ni mahal mo ni susunod na. Kasi kay kana ra mo yung guba na yun. Pero kana ipugnaw na siya. Ay, okay. Ay, ano, okay. Oh, oh,
Do we have BCE?
ang sa to, Juan,
10.
ang 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 aircon murag pila na to ka buwan, ako to palipihan ko puhunsan. Oh, schedule lang ako. Ingnon talaga. Yan, nai video diyan tawag mo sa overload sa picture niya dali nga nagawa. Ah, ang imo refrigerator niya, okay ba? Ang imo ref.
Di ba?
At pasig mo mag-defrost kay paano na every week or 2 weeks defrost sa inyo na. Huwag sa siya ba? Non-frost eh. Sige.
Ano siya class? Galit. Pasensya na kayo mo. Wala ko sa utak ron. Okay. So, are you still there?
Yes, miss.
Yes,
Yes,
ma'am.
Miss.
Oh my God. Okay. So, in here, pagpangita sa itong RC, we're gonna use the loop for our here. VCC, ICRC, VCE, IERE. Okay. That one. Naglibot ko kanina class kay akong nasod sa kung nahuna kay katong VCC IC I think it's here. Kani gani nga formula. Muna akong gisod sa kung nahuna. Gi-equate na ko zero which is BCE din na siya. Diba bongga? So naloka ko kalit. So muna na siya. Akong gibag-o. Ang answer na is 2,800. Okay, naka-remember ko, dili o dyan na 1,600. Kung na-remember is 2K dyan to siya kapin ang RC. Okay. Palihog na ko kopya or screenshot sa inyo. Hadi ka? Pasensya kayo kung naglibog pod mo. So we already have our R1 and our RC. So for the next topic here is the last topic for the VJT. This is the voltage feedback. It is an improved level of stability that can only be obtained by introducing a feedback path from the collector to base as shown on the figure. Almost the same with voltage divider bias but with less resistor. It is also called self-bias or collector feedback. Now, in here class, it's this, mura siya pare-pareha sa atong emitter stabilized or emitter bias, right? But sa atong emitter bias, oh, sa atong emitter bias class is in here, here. Ang ato ang emitter bias is before sa collector na resistor na diha ang atong source. Okay? Now, but with the voltage feedback, it is with after our ano ang section dahil? Okay. So this one right here, ang iyahang base na connection is wala siya before sa atong collector resistor. Naa siya after sa atong collector resistor. And this is the general circuit for our voltage feedback. Naa siya sa atong base nga resistor na connect siya sa atong after na sa atong collector nga resistor. Okay. Now in here, the figure shows the base emitter loop for the voltage feedback configuration. Writing Kirchhoff's voltage law around the indicated loop in the clockwise direction will result in VCC minus ICRC minus IBRF minus VBE minus IERE. When you loop here, that's positive VBC minus, okay, RCI, IC bar, IC. Gitawag na siya IC bar class. Why? Because gi-denote na siya of IC bar because that current is flowing, okay, na siya sa atong RC, after na siya sa atong RC. Okay? That's the denotation of our IC. Wala pa siya kasud sa atong base, muna na ang atong IC bar. Okay? Muna itong VCC minus IC bar IC minus IBRF minus VBE minus IERE. It's the same, ang pag-compute class is the same ra siya sa IC, but gidenote lang siya diri nga IC bar because we are doing voltage feedback. And the current flowing this kani nga IC bar is wala pa siya kaabot sa terminal or node wherein diha nakakonekta ang atong resistor sa base. Okay, so it is important to note that the current through RC is not IC but IC bar, wherein IC bar is equal to IC plus IB. Current entering is equals to current leaving. The currently enter is the IC, and the current nga ni leave is the IC. Current nga ni enter is IC bar, ang current nga ni gawas kay si IC IB. Now, however, the level of IC and IC bar far exceeds the usual level of our IB. And the approximation of IC bar is equal to IC ra, which is normally employed. Why? Okay, even though naka IC bar na siya class, di ba IC bar is IC plus IB. But IB is almost negligible in value because it has a very, very small value na siya in micro. So therefore, IC bar is equals to IC. Now substituting IC bar, which is equals to IC, and IC is equals to beta IB, okay? And remember, IC is also equals to our IE, right? IE is equals to IC, which results in VCC. In here, inisa nimo og beta IB because IC bar is equals to our IC. So that's beta IBRC minus IBRF. RF na siya class because that's the resistor feedback for our base. Minus VBE here. Minus, it's supposed to be IERE. But remember, our IE is equals to IC. And that is beta IB. So that's beta IB, RA equals to 0. That's the loop and the configuration for our voltage feedback. Now gathering the terms, we have VCC minus VBE minus beta IB RC plus RE minus IB RF. Kopyahan tani. They have the same with beta IB. So iyang gisagol ang common nga term. So that's beta IB or very common nga variable. So that's beta IB RC plus RE plus na siya. Okay, because when you distribute the negative sign, that's negative beta IBRC minus negative beta IBRE. Then i-minus ni mo ang habilin, which is IBRF equal to 0. And solving for IB yields, imo na siya i-manipulate plus, mo ni siya ang formula. IB equals BCC minus BBE overall RF plus beta RC plus RE. Follow.
Yes, Miss.
Okay. That's the solving for our IB. Now, once IB is known, IB na siya. Kaniya, wrong na siya. IB, once IB is known, makakuha ta ni IC, beta IB. Now, once IC is known, the collector to emitter voltage is determined by the same sa ato ang voltage divider. VCC minus IC RC plus RE. Okay, we have here an example. Determine the IC and BCE following for the voltage feedback configuration. Oh my God. IC can be found using our IB. So that's IB. What's the formula of our IB? That's VCC minus BBE divided by RF plus beta RC plus RE. What can you observe, class?